So we're going to start into Chapter 6. Chapter 6 deals with quadratic equations and inequalities. You've already dealt with quadratic equations. We dealt with those back in Chapter 3. We learned how to solve quadratic equations, and back in Chapter 3 we learned that the only way to solve a quadratic equation, as far as we knew then, was to factor it and then set each one of them equal to 0 and go from there. Well, now what's going to happen is we're going to have quadratics that deal with not only real numbers, which are from negative infinity to positive infinity, but we're also going to deal with a new set of numbers called complex numbers or imaginary numbers. So we need to go ahead and learn about the imaginary numbers, and then we'll go back to the quadratics and finish learning how to solve these quadratic equations. So the first thing I want to talk to you about is the complex number. That is the imaginary number, and it is denoted with I. I is just a variable. It's just like X, it's just like S, it's just like T. However, when I say what mathematical formula does little m represent? What would you tell me? Little m represents what? Slope, and most people know that. What if I asked you about D? D would represent what? Distance. What about T? Little t would represent time, okay? So I is just a variable, just like those that I just gave you an example of. It's just a variable. It's just that the variable I, represents these complex numbers. And so when you look at these numbers and you see the variable I, understand it's not just another X. Okay, there's something going on there. So the main two things that I want you to understand are the ones that are right here on the bottom. The first one is if I have the square root of a negative number. Up until this point, we haven't taken the square root of a negative number, because up until this point, we've dealt with just real numbers. And I told you that you can't take the square root of a negative number. Well, now I'm going to adjust that statement just a little bit. You can take the square root of a negative number, but you're going to get a different set of numbers. Okay? Or you can't take the square root of a negative number and stay in the real numbers. Okay, you're going to have to go over to the complex numbers, the imaginary numbers. So anytime you see the square root of a negative number, to get rid of that negative underneath the radical, which is the first thing we need to do, is you're going to pull out an I. And I'll show you in just a second. The other thing that I want you to understand, because we're going to start multiplying these, and you know that I times I is I squared, just like X times X is X squared, I times I is I squared. So anytime in your mathematics you come up with an I squared, understand that I squared is the same as negative 1. It's the exact same thing as negative 1. Because look at this. If I is equal to the square root of negative 1, and if I square both sides, I get I squared is equal to, what happens when you square a square root? They cancel out and you get the radicand. So that's why I squared is equal to your negative 1. So just kind of remember these things. We're going to turn the square root of negative 1 into I, always. And we're always going to turn I squared into negative 1. So commit those to memory. Write them down and make sure you know them. Alright, so let's look at this. This looks like, kind of like something that you know how to do. You know what the square root of 49 is. What is square root of 49? Square root of 49 is just 7. But that's not what we have. We have the square root of negative 49. So what's going to happen really and truly, what you're looking at is this. Negative 1 times 49. Negative 1 times 49. It's just like if we had the square root of 26 or 24, and I taught you how to break them up into 4 times 6 and then bring the 4 out as a 2. You're going to do the exact same thing. So what is the square root of negative 1? I. And what is the square root of 49? 7. Now, if I asked you to write this in algebraic order, what would you write? 7i. Okay. So just understand that that's going to be 7i. Okay, letter B, watch what happens. We're going to break this into -1, because I see the negative in there, times 9 times 5. So the square root of -1 is going to be I. Square root of 9 is going to be 3. And you can't do anything with the square root of 5. So this turns into 3I square root of 5. Okay? So, as you start doing these, as you start working on these in your study guide or in class or whatever the case may be, anytime you see a negative number underneath a square root, it has to be a square root because we can take the cube root of negative numbers, right? If you see a negative number under a square root, just make your life a little bit easier and pull out an I. Pull out an I and just go with it. Okay? Right here. Pull out an I and just go with it. Alright. So, a complex number is any form of the standard form, a plus bi. And the reason why this slide is in here is because when you check your answers in the back of the book, your answers are going to be given to you in complex standard form. Okay? A plus bi. A is your real part and bi is your imaginary part, your complex part. So when you check your answers, that's what you're going to see. And not to mention the fact on the final exam, your final exam is multiple choice. And the answers are going to be in this form as well. So I don't want you to be thrown off by your answer versus their answer because you may have the exact same thing. It's just written a little bit differently. Okay? So just be aware of that. Again, A is the real part. And B is your imaginary part. So on these problems here, technically if the directions say write your answer in complex standard form, we don't have a real part. So it's 0. And then you have your complex part 7i. Okay? So that's how you would write that answer in basic complex standard form. You got to have a real part and you got to have an imaginary part. Now, if the directions do not say write in standard complex form, don't worry about it. Don't even worry about it. All right. So let's start doing the math with these complex numbers because that's what we're going to do. We're going to relearn how to add, subtract, multiply, and divide all these things. So adding them is just combining like terms. You're adding the reals to the reals and the complex to the complex, and that's all you got to do. Okay? So 3 plus 5i plus a -2 minus 7i. What do you think you're going to get? Real with real and complex with complex. Like terms. What? Okay. 3 plus -2 is going to be 1. And 5i plus -7i is going to be a -2i. All you're doing is combining like terms. Your variable terms and your non-variable terms. Your reals with your non-reals. So letter B, what do you think you're going to get? What you going to get, Shane William? -4 and -2, what do you get? -6. And then 1 minus a -5. 1i minus a -5i. No. There you go. 1 minus a negative, that goes a plus, so you have 1 plus 5i. 1i plus 5i is going to be 6i. Channeling kind of got taken over there, but that's okay. So you have -6 plus 6i. And again, all you're doing is combining your like terms, just like you learned how to do in chapter 3. Okay, so what about multiplying? We added, we subtracted, now we're going to multiply. To multiply these things, your rules are the same with regular polynomials. You're going to have the distributive property, you're going to have the full method, all that kind of stuff. You're going to have your patterns that we talked about in chapter 3. Everything's going to come back around here. So a couple of things that you need to remember is if it's in radical form, you need to go ahead and express it as a complex number. Okay? If it's in radical form, we need to go ahead and express it as a complex number, and then you're going to find the product. If it's already in complex form, you're just going to do your multiplication like we learned how to do in chapter 3. And here, remember, I squared is -1. Anytime you come up with an I squared, replace it with a -1. Replace it with a -1. So here, it's in radical form. Are we just going to start multiplying? Yeah, if it's in radical form, we do not need it in radical form. Okay? You can't, because if you did like we did in chapter 5, and we said, okay, well, at the square root of -16 times the square root of -81 is going to be the square root of positive something, 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 and then you take the square root of that, and you're going to get 36. 36 is close, but it's not the right answer. Watch what you have to do. You have to get it out of this radical form first. So the square root of -16 is going to be, what do you think? 4i. Good. Because that negative is -1. Square root of -1 is I. And square root of 16 is 4. And then we're going to multiply that times the square root of -81, which is going to be what? 9i. So 4 times 9, there's your 36 that you were wanting. And then I times I is going to be I squared. But every time you see an I squared, you're going to replace it with a -1. Every time. So your answer is going to be -36. Okay, letter B is a little tricky. How would you simplify the square root of -5? You can, just a little bit. What would you do? What's the square root of -1? I. So you have I square root of 5 times what? What about the square root of -10? Yep, I square root of 10. Now we can do what we were doing a while ago. Because I times I is going to be I squared, and the square root of 5 times the square root of 10 is going to be the square root of 50. Well, let's simplify this. What do you think? I squared is going to be a -1. We already know that. What is the 50 going to break into? So you're going to get -5 square root of 2. -5 square root of 2. Now, again, if you wanted to do the one on the top the same way, you can. That would be I square roots of 16 times I square roots of 81, but it's still going to be the same thing. You have 4i times 9i. So either way. So, anytime you see a negative in the radical, what are you going to do? Pull out an I. Anytime you see a negative underneath the radical, you are going to pull out an I. Alright, you recognize this? Distributive property and full method. Distributive property and full method. So we're going to have 2i times 4, which is going to be 8i. And we have 2i times -3i, which is going to be -6i squared. Anytime you see an I squared, you're going to replace it with what?
-1.
So what is -6 times -1? Yeah. And to get it in complex standard form, remember your real needs to come first and your imaginary comes second. So you're going to get 6 plus 8i. All right, letter B. Pull this out. Do the full method on this. Distribute it out. Effort goes a long way. Push a pencil. All right, so division. We've added, we've subtracted, we've multiplied, now we're going to divide. when you look at this problem, both of these problems, you're thinking, well, is it not already simplified? Not if you know what I is. What is I? I squared. What is I? Square root of negative 1. I is a radical. I is a radical. I can do this. And it's the exact same thing. What are you going to tell me? You cannot have a radical in the denominator. Which means you cannot have an I in the denominator. You cannot have I in the denominator. Because if you do, you have a radical in the denominator. So how are you going to get rid of that I? It's really simple. You learned it in chapter 5. If I want to get rid of the square root of negative 1, what am I going to do? I'm going to multiply the top and the bottom by the square root of negative 1. But if I want to put it in imaginary terms, I'm going to multiply the top and the bottom by I. Because you're going to multiply the top and bottom by I. So I have 3i on top, and on bottom I have 10i squared. And then you're going to think, oh, well, the i's will cancel out. Well, what would happen if you canceled out the i's? It'd take you right back to the beginning, so don't do that. But instead, what is I squared? I squared is negative 1. So you're going to have 3i over negative 10. And there's your answer. Okay, so what's wrong with letter B? There's an I in the denominator. That's the problem with letter B. How are we going to fix it? You're going to multiply the top and the bottom by I. Now, go ahead. The i's? No. Because if the negative 2 had an I, you could. If the negative 2 had an I, you could definitely cancel those. So on top, what are we going to do? What's the property called? Yeah, it's the distributive property. So I times negative 2 is negative 2i. And I times 6i is positive 6i squared. And then 3i times I is going to be 3i squared. Here, Chloe, you could cancel out all the i's, but why would you want to do that? Why would you not want to do that? If I canceled out all the i's, what would happen? You'd undo what you just did and then take you right back to the beginning. So you definitely don't want to do that. Instead, let's fix all of our I squares. So on top, we're going to have negative 2i minus 6, right? Because this is a negative 1. Oh my God, that's written. And then on bottom, we're going to have, what snotty figures. On bottom, we're going to have a negative 3. Do you see what happened? 6i squared turns into 6 times negative 1, which is negative 6. 3i squared turns into 3 times negative 1, which is negative 3. Now, if you want to cancel out all those negatives, you can. Not necessary, but if you wanted to do that, that's fine. But that's all you can do. Why can I not reduce the 6 with the 3? Why can I not reduce the 6 with the 3? The top is a group. The top is a group. Y'all remember that. Okay, conjugates. I need you to understand. I need you to make a big, huge note in your notes about what I'm about to say. Because if you don't, you're going to get very, 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 very confused. Okay? Do you remember what conjugates are from chapter 5? Okay. Notice the difference. Are you watching? Look at the screen. And look at the denominators. And tell me the difference between these two problems and these two problems. Looking at the denominators only, tell me the difference between these two problems and these two problems. These two problems have addition and subtraction. That's the only time you're going to use the conjugate. That's the only time you're going to use the conjugate, is if you have addition and subtraction in your denominator. Okay? If it's like the previous slide, and this is the problem. The previous slide, you get this fairly well. The problem is when I give you the test and you see something like this, all you want to do is multiply the top and the bottom by I and you're done. That's wrong. And when you start working it out, you're going to be like, this is not right. Something's not right. What's not right is you're not using the conjugate. So if you see a plus or minus in the denominator, conjugate, 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 conjugate. Okay. So what is the conjugate of 5 minus 3i? Good job. All right, so to work this out on the top, what are we going to have to do? I hear it louder. Distributive property. So 2i times 5 is going to be 10i. And 2i times 3i is going to be 6i squared. On the bottom, we're going to get 5 times 5, which is 25. And then negative 3i times positive 3i is going to be negative 9i squared. All right, so let's fix what we can. On the top, we're going to have, I'm going to combine two steps in one, so watch what I'm going to do, okay? I'm going to take that I squared, it's going to be negative 1, I'm going to change that into a negative 6, and then I'm going to write it in standard complex form, okay? So we're going to have negative 6 plus 10i. Are you okay with that? The 6 times the I squared is the negative 1. Negative 1 times 6 is going to be negative 6, but that's going to be your real part, so it needs to come first. So you're going to have negative 6 plus your imaginary part, which is going to be 10i. Now on the bottom, let's think about what happens. What happens with that negative 9i squared? It's going to go to plus 9. And then 25 plus 9 is going to give us what? 34. We have one more step. Can you tell me what it is? One more step. You can reduce. You can reduce by what? 2. So the negative 6 divided by 2 is going to be a negative 3. The 10i divided by 2 is going to be a 5i. And 34 divided by 2 is going to be a 17. So we're going to have negative 3 plus 5i over 17. And there's your answer. It is, but we can reduce all of it by the same number. If you can reduce all of it by the same number, you're good. Okay. I want you to write down on your paper for this next problem. I want you to write down what you think the conjugate is. Write it down. What do you think the conjugate is for this problem on the bottom? You got it written down? Okay, let's see if you got it right. The conjugate is negative 2 minus I. The only sign that you're going to change is the one in the middle. Okay, that negative needs to stay where it is. The only sign that you're going to change is the one in the middle. Alright, so now that we've got the conjugate situated, let's do all this algebra. On the top and the bottom, it's full method, okay? Especially on top. On top, we're going to definitely do the full method. So you have negative 3 times negative 2, which is going to be 6. You have negative 3 times negative I, which is going to be positive 3i. You have 8i times negative 2, which is going to be negative 16i. And then you have 8i times negative I, which is going to be negative 8i squared. Now on the bottom, you know it's a pattern, right? So do I have to do the whole entire full method? Which two can I do? Between the F, the O, the I, and the L, which two do I have to do? The F, L. No OI. The middle ones, just leave them out. So we're going to do first times first. Negative 2 times negative 2 is going to give me 4. And then I times negative I is going to give me negative I squared. All right, let's clean this up. What do you want to do? There's a bunch of things we got to do. Tell me one.
Combine the I.
Okay. So we want to combine these two. So we're going to have 6 plus negative 13I minus 8I squared over 4 minus I squared. That's one of the things that we needed to do. Combine like terms.
8 becomes positive and you add 6.
Okay. And we can do that all in one step, I think. Negative 8I squared is going to become 8, and then we're going to combine it with the 6. So now what we have is 14 plus, not plus, 14 minus 13I on top. What about bottom? Well, there's a 1 here. So what are we going to get? Negative 1 times I squared is going to give you what? I squared is a negative 1. It already has coefficient of negative 1. Because if you have negative x, there's understood to be a 1 there. So if you have a negative I, no, because what you have is you have negative 1I, so you have negative 1 times negative 1, which is positive 1. So you're going to have 4 plus 1. So you're going to get 5. Negative times negative is positive. All right, and we can't reduce that, so that is going to be your answer. That is going to be your answer. All right. So like I said, what we're going to do now for the remainder of Chapter 6 is we're going to learn how to solve these quadratic equations. You only know of one way to solve a quadratic, and that is to factor it. You got to get it set equal to 0. Once you get it set equal to 0, you factor the left-hand side, set each one of those factors equal to 0, and then go with it. We did that in Chapter 3. So, how do you know if you're looking at a quadratic? We've talked about this multiple times in this class. How do you know you're looking at a quadratic? That's a trinomial. What? No, anything can be set equal to 0. The squared term. When you see this, you are looking at a quadratic. In 112, you're going to be looking at a bunch of these. These will graph a parabola. Okay, these will graph a parabola. So what's going to happen in 112, right off the bat, day 1, you're going to see these quadratics. And you're going to have to know how to work with these quadratics. So Chapter 6 is extremely important for those of you who are going to 112. How many of you have to take 112? If you're transferring to a 4-year school, you have to take 112. How many of you are taking 112? Okay, a little bit of counseling. All right. So, when you have a quadratic, again, like I said, you already know how to solve by factoring, but I'm going to show you 3 other ways. I'm going to show you the square root property, I'm going to show you completing the square, and then I'm going to show you the McDaddy formula, which is called the quadratic formula. Okay? So, factoring. This is just a review. You should know how to do this. It's already set equal to 0, so we're good. What are we going to do on the left-hand side? How are you going to factor the left-hand side? Thank you. Factor out a 7x. If you factor out a 7x, you're going to have x minus 2 is equal to 0. Then what? Take each one and set them equal to 0. And so x is equal to 0 and x is equal to 2. And what you've done is you have found the x-intercepts of your parabola. The only thing you would need in order to graph it is your vertex, and we're going to talk about that in 112. But basically what's happening is it's saying that this parabola is going to cross through the x-axis at 0 and 2. Okay? All you got to do is find the vertex. That's 112. All right. The other one I wanted to do was this one. Factor this. Factor this. Solve for x. Solve for x. Solve by factoring. Now, on the PowerPoints and well, no, not on your study guide, but in the PowerPoints, I will tell you what I want you to solve by. Solve by factoring. Solve by square root property. Solve by quadratic formula. When you get your test a week from Wednesday, which is your next test, it's just going to say solve. You can do it any way you want to. You can factor. Some of them won't factor, so don't let that be your catch-all. You can use quadratic formula on every single one of them if you want to, as long as you keep your math straight. So anyway, does anybody have this factored yet? Well, can we multiply together to get 29, but add together, or multiply together to get 120, but add together to get 29? Thank you. All right, so we get x plus 6 and 4x plus 5. Take each one of these, set them equal to 0. And those are your two answers. Again, that's where the parabola is going to cross the x-axis. What did I do over there on the right-hand side? Bottoms up. On the right-hand side, I did bottoms up to factor that. That should look familiar to you. Don't forget it, unless you want to learn how to do factoring a different way, which is fine. Okay, so there's your quick review of factoring. So now let's slow down just a little bit and talk about square root property, because we're going to learn how to do the square root property, and then we're actually going to apply it when we complete the square. So make sure you know how to do this so that when we start completing the square, you'll know where to go. All right? So you know that if you have x squared is equal to a, then x is equal to the square root of a. What'd you do? You took the square root of both sides, and you get x is equal to the square root of a. All right? Y'all know how to do that. We've done that before. Or you know that if x is equal to negative square root of a, or x is equal to the square root of a plus, or x is equal to negative square root of a, the way that we're going to start writing this is use the plus or minus symbol. So, for example, if I say x squared is equal to 9, and I wanted to solve for x, you know that we're going to take the square root of both sides, and you're going to get x is equal to plus or minus 3. We learned that in chapter 5. When you take the square root of a number, technically you get two answers, the positive and the negative. Reason being is because 3 times 3 is 9, and negative 3 times negative 3 is 9. So don't forget, you are going to get those two answers. That plus or minus symbol means plus 3 and minus 3. That is two separate answers. Don't forget that. All right, so try these two. Try letter A at least. You can do A, I know. You can do it in your head. What are you going to get? Plus or minus 9. Not plus or minus 3. Don't keep going, okay? The square root of 81 is 9. Don't keep going and take the square root of 9 again. Once you take the square root, the square root symbol's gone. So it's plus or minus 9. Now letter B, there's a little bit of an issue. Before you can do the square root property, listen to me now, because you're going to hear it again in a minute. Before you can take the square root property, before you can use the square root property, the part that's squared needs to be by itself. So in other words, I need to get x squared by itself. So I'm going to divide both sides by 3. So I'm going to have x squared is equal to what, 15? Now I can use the square root property. So I'm going to divide both sides by the square root. Not divide both sides. I'm going to apply the square root to both sides. So you're going to have x is equal to plus or minus. You can't do anything with the square root of 15. Now that is some decimal. So in 112, if you had to graph this, then you would just type square root of 15 in your calculator and you come up with a decimal. So it would be plus something, 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 and minus something, something, something. Okay? All right? What if our squared term is a group? What if our squared term is a group? Well, in order to solve this equation, what needs to be by itself? The x needs to be by itself. Look at this. In order to get to this x, number one, it's embedded in a group. And number two, that group is a group because I'm squaring it. I've got to fix both of those things before I do anything else. So let's start with this square first. How do I get rid of this square? Take the square root. Take the square root of both sides. And guys, listen to me. Anytime you write down that square root symbol from this point forward in this math class, when you write down that square root symbol, when you initiate a square root, when you put a square root in the problem, you've got to do the plus or minus. If it's already there, don't worry about it. But if you initiate it, you put it there, like I just did that blue one, you've got to do plus or minus. Okay? So this is going to be x plus 4, because this cancels out this, is equal to plus or minus the square root of 100 is 10. Do you see what I'm saying? When you put that square root symbol in there, you've got to take the plus or minus of it. Now watch what happens. In order to solve for x, I've got to get rid of the 4. But since this is a quadratic, how many answers should I expect? 2. You should always expect 2 answers. Watch this. I have 2 separate problems here. I have x plus 4 is equal to positive 10, and I have x plus 4 is equal to negative 10. Because when you take the square root of 100, it's positive 10 and negative 10. So you have to use both of those. And that's where your 2 answers are going to come from. So x is going to be equal to 6, and x is going to be equal to negative 14. Okay. The problem on the right. There are so many things that I've got to get rid of, it is not even funny. Not even funny. What do you think is going to be the first one we're going to get rid of? Marcus? What's going to be the first thing I get rid of? No. That's not going to get rid of anything. Yeah, the plus 5. I need to get rid of this plus 5, so I'm going to minus 5 from both sides. So we're going to have 2 times 5x minus 2 squared is equal to 20. Jake, what's the next thing I'm going to get rid of? Not yet. The 2. We're going to divide by 2. So we're going to have 5x minus 2 quantity squared is equal to 10. Leslie, what do you think we're going to do now? going to square root both sides. So we're going to have 5x minus 2 is equal to, now watch this. When I take the square root of 10, the big difference between this problem and the previous problem, look, is over here, when I took this square root, I can take the square root of 100 and get plus or minus 10. Here, however, I can't take the square root of 10. I can, but it's going to be some decimal, and that's just not what I want. Okay? I can't take the square root of 10. So when I write this down, I'm going to have plus or minus the square root of 10. There's nothing I can do with that. It's just plus or minus the square root of 10. It's going to be some decimal, but we're not going to worry about that. Now, I've still got to get rid of it. I've still got to get x by itself. I've still got to get rid of a few things. What's the first one we need to get rid of? Yeah. So we're going to add 2 to both sides. And I want you to watch this step really, really closely. Are you watching? This plus or minus symbol, what does it belong to? The square root of 10. This plus sign, what does it belong to? The 2. Can I combine the square root of 10 and 2? No, one's a whole number and one's a radical. I cannot put any of these together, so I'm just going to have to write them down. But make sure you know what sign goes with what, because watch what's going to happen. You're going to get 5x is equal to 2 plus or minus the square root of 10. You can't put them together, and that plus or minus symbol goes with the radical, always. What's the last step? Yes. So we're going to get x is equal to 2 plus or minus the square root of 10 over 5. And this is another way. This is the third way to solve a quadratic. You know that you can factor. You know that you can use the square root property. That's what all this is on the board. Okay, factoring would be like number 13 and number 7. Square root property would be all the other ones. So there's 2 ways that you know to solve a quadratic. Now, the third way is completing the square. And like I said, when you get into 112, you will complete the square a bunch. A whole bunch. A whole bunch. So make sure you know how to complete the square. Step number 1, make sure your leading coefficient is 1. If not, you need to divide by your leading coefficient for every single term. Okay? Step number 1, make sure your leading coefficient is 1. If it is not 1, then you need to divide by that leading coefficient for every single term. So for example number 13. If on number 13 I asked you, that's the one that's over there on the board, if I asked you to solve number 13 by completing the square, the very first thing you would have to do is you would have to divide 2x squared by 2, 19x by 2, and 24 by 2, and of course 0 by 2. You would have to divide everything by 2. Your leading coefficient has to be 1 before you complete the square. Okay? Step number 2, what you're going to do is you're going to move the constant to the opposite side of the equal sign. So for example, go back to number 13. You're going to take that 24, which would now be 12 because we divided by 2, and you're going to move it to the right side of the equal sign. So now you're going to have x squared plus 19 halves x is equal to negative 24. You're going to take that 24 and move it over to the right. Okay? So second step, move the constant to the opposite side of the equal sign away from the 2 variable terms. What's going to happen, and what I like to do is at that point, when I've moved that number over, I like to put a point. So in other words, if we had x squared plus, and I'm just going to put another number here because I don't like the 19 halves, I'm going to put 4x plus 12 is equal to 0. So you're going to move your constant over. And you know that this is going to go away. But what I like to do is I like to put plus a blank. It's always plus a blank. is equal to negative 12. So instead of just marking that off and getting rid of it, I want you to do plus a blank. And if you're going to add something to one side of an equation, you've got to add that exact same thing to the other side. If you do the plus a blank on both sides, it will remind you, oh yeah, I've got to do something here. And I've got to do it on both sides. Okay? So when you move that constant over, put plus a blank on both sides. Because you're going to add something on this side of your equation, which means you guys keep it balanced up and add it on that side as well. So what are you going to add? Put a big, huge star or circle around this right here. Pretty it up for you on the paper so you'll see it. Because if you can't do this, then you can't complete the square. The stuff that we just did, that's easy. Dividing by a number and then moving a number over, that's the easy stuff. So what goes in this blank? Well, when you have a quadratic, and I don't think you saw it in high school, but we haven't talked about it in this class. When you have a quadratic, you have an A term, a B term, and a C term. Well, we have talked about it because we talked about multiplying A times C. Look at this. It says take half of the middle term and square it. That middle term is called B. A, B, C. Take half of your middle term and square it. So this is where this formula comes from. You're going to take half of B, B is your middle term, and then turn around and square it. So tell me, what's half of 4? 2. And 2 squared is going to be? Completing the square. And you just completed the square. I'm telling you, this stuff right here is crucial. You got to know what your middle term is. You got to take half of it and then turn around and square it and add it to both sides. Now, on the left-hand side, you're going to be able to factor this. Can anybody tell me what this is going to factor into? X plus 2 and x plus 2. But we're going to write it like this. And then simplify that over there. You know what to do from here? Because we're still trying to get to x. You're going to do exactly what we were doing previously. You're going to use your square root property, take the square root of both sides, and continue to solve. Okay? Completing the square. It's a lot of steps. A lot of steps. Number 1, make sure your leading coefficient is 1. If not, divide everything to make it 1. Number 2, take that constant and move it over to the other side and put your blank in on both sides. What goes in the blank? Half of your middle term squared. Half of being squared. Fill in those blanks. Simplify what you can. That left side will always, if you do it correctly, that left side will always factor into a binomial square. This is your pattern that we talked about. This is a perfect square trinomial, and a perfect square trinomial will always factor into a binomial square. Okay? So this should always happen. And then over here, you can just put those together. From there, you use your square root property and continue to solve. Use your square root property and continue to solve. We will pick up here.